All right, so let's continue the review here. We're on section 4.2. In 4.2, we're dealing with net ionic equations. And so one of the things you need to do here is determine what ions are going to be remaining in solution that are actually part of a reaction. So let's kind of go through this here. We'll go through one entire net ionic problem here. So let's look at this example here. We'll take the example where we have ammonium chloride. So let's go ahead and say NH4 Cl. And this is going to be combining with silver metal. So let's say Ag, and this is going to form a product. And so normally you won't be asked to predict the products at the same time that you're asking to do a net ionic equation, as those types of things are separate. But here, let's just give you the full reaction here. You're going to wind up getting AgCl, and you're going to wind up getting NH4 ions. So here, the overall thing that we got to consider is make sure that we've got the solubility is identified. So the NH4Cl is aqueous. The silver here is a solid. The AgCl, if you look at solubility rules, is going to be a solid. So that's important to us. And then lastly, NH4Aq, that's an ion. So the main thing to pay attention here is that we actually formed a solid. This is actually going to be one of the other types of chemical reactions in which we form a precipitate. That's a precipitate reaction. So if we take the step here, now that we've identified the predicted compounds, let's go ahead and put charges on everything. And so NH4, this entire thing here is a +1. The chlorine is a -1. Silver is a 0 charge because it's by itself. And then chlorine, when it's bound to silver, silver becomes a +1, chlorine's a -1. And we've already got the charge for the ammonium here. And NH4 is a +1. Now that we've got all of this here, the main thing we need to do now is to go ahead and break up any compounds that are aqueous. So here we've got an aqueous, and we've got an aqueous over here, so we've got to go ahead and break those apart. We're going to leave the solids by themselves, but in this case here, the first compound, we're going to break this apart into the very respective things. But before we can do that, we got to make sure that the entire reaction here is balanced. So let's go ahead and look at NH4. We've got one copy on the left-hand side. We've got one copy on the right, so that's good there. One copy of the chlorine, one copy of the chlorine, so that's also good there. We've got one silver on the left-hand side, one silver in the product. So what the coefficients are going to be here for this reaction are going to be a coefficient of 1, 1, 1, and 1. So now that we've got this information, the next thing for us to do is to find out here, we break this apart. We break this apart, and we've got NH4 breaking apart and Cl breaking apart for the aqueous compounds. So this particular compound here will break up into two parts. And so that should break apart into the following. So we're going to get here, we're going to get an NH4 plus, and we're going to get one copy of that. And then we're also going to wind up getting here one copy of the Cl minus. And that'll come from that first compound. And so all we've got here are these two things broken up. Now, I won't repeat the same lines up that I've done here. I'm not going to put these lines for the rest, but the similar process that we did here for the first compound, for any other aqueous, we're going to bring that down. So if we keep going across, and let's go ahead and write down here, we've got one copy of the silver. Now, the silver is going to be a solid. We're going to put the silver here as a solid by itself. And while we're at it, let's go ahead and put everything else back here. We're going to put aqueous and then aqueous here. And this is going to form one copy or 1 mole of the sodium chloride, AgCl. This is also in solid form. And then lastly, we're going to form here and get one product of ammonium, NH4 plus. And that one there is going to be designated as aqueous. At this point here, since this is known as the ionic equation, and so let's label this here, this is ionic equation. In the ionic equation, you want to locate all those ions that exist on both sides of the reactant. So here the arrow is going to separate left and right. So on the left side, we've got an ammonium ion, and on the right, we've got an ammonium ion. So what I'll do here is I'm just going to go ahead and underline these squiggly lines here. These are known as spectator ions. And so we want to make sure that these spectator ions are going to be eliminated. from the final net ionic equation. So what we'll do here is identify them. We know they're there. And then identify the solid. Notice the solid is composed of silver and chlorine. Those are the only two things that should be on the reactant side as available to contribute to the formation of this solid precipitate. So here we've got 1 chlorine mole, because we got 1 mole of a silver, and then we 1 mole of silver, 1 mole of chlorine, so we've got that ratio there. So the only items that are actually going to be involved in the formation of silver chloride are going to be the silver ions, or the silver metal, and the chlorine ions here. The spectator ions, we can go ahead and eliminate them from the mix. And so when we write our final equation, we're just going to include only those species that led to the formation of the solid. So in this particular case here, it's just going to be these items here, which I'm going to make a copy, bring this down. And so this item down here at the bottom, I'm going to put this in a red box. This part right here is known as the net ionic equation. And this is the thing that you're going to be asked to identify or find in any kind of net ionic problem. It is a little bit lengthy in the terms that you have to do a couple of steps of work. You have to identify charges. If you're asked to make the prediction, you have to make the prediction. But once you've identified charges, you need a balance. See the coefficients here. And then once you balance, identify the spectator ions, eliminate them from the ionic equation, and whatever remains is part of the final balanced reaction that is part of your net ionic equation. Now, you should be prepared at this point to actually do some math with respect to these in terms of how much of a specific ion is formed if you have all of this work done. And so what I'll do here in the last couple of minutes is go through one sample in terms of identifying how much product you should get when you incorporate some of the stoichiometry into this. Now we'll see the stoichiometry work up here in the next section, up in when we get into section 4.5. But for right now, just be prepared to identify the net ionic equations. So that'll bring 4.2 to a close here in terms of what you should be able to do. Practice some other problems. There's plenty of them that I shared in class. But we'll see you in the next video as we continue on to section 4.3. So we're going to leave this alone.